Assalamualaikum and hi everyone. The innovation presented is the ZAP Method from Kolej Vokasional Setapak. This video introduces the ZAP Method, a simple and structured approach to help students understand electrochemistry, especially in identifying cations and anions and tracking their movement during electrolysis. Represented by Puan Ira Nusrat binti Jaafar, Puan Fazura binti Muhammad Setia, Dr. Khatijah binti Abu Bakar, Puan Nurul Salimah binti Ambrose, Puan Marhani binti Muhammad, and Puan Nik Nur Maisarah binti Nik Muhammad Salim. Observations during lessons showed the semester 4 SVM students struggle to identifying cations and anions and determine their movement to the anode or cathode. This confusion caused low interest, passive learning, and weak assessments result. Electrochemistry became the lowest scoring subtopic due to poor understanding of passive electrolysis. These issues showed the need for a more effective teaching approach. The study focuses on three main objectives. First, to identify sources of confusion related to ion types and ion movement. Second, to describe how the ZAP method enhances conceptual clarity. Third, to evaluate the method's impact on student participation, interest, and understanding. ZAP method is a simple guide to help students understand ion behavior in an electrolytic cell. Z stands for zone, where cations are placed on the left and anions on the right to help students classify ions easily. A stands for direction, reminding students that cations move to the cathode and anions move to the anode, supported with visual arrows and colors. P stands for movement, where students trace the actual path of ions. This clear pattern, cations to cathode, anion to anode, reduces confusion and improves memory. This is the ZAP method flashcard. Zone A and B marks the least severe aqueous and molten solutions. The Zone C marks the direction of anion, while Zone D marks the direction of cation. To prepare the card, fold zones A and B backward to form two main zones, left for cations, right for anions. Then, fold zone C forward for the cation's movement direction and zone D forward for the anion movement direction. Besides the ZAP method flashcard, the ZAP method is also provided in an interactive simulation. The ZAP method interactive simulation can be used in class to help students practice, check their work, and visualize ion movement for better understanding. Now, let's explore the ZAP method interactive simulation. Click any aqueous or molten solution and see the cations in blue and anions in red separate. And watch the cations move to the cathode and anions to the anode during electrolysis. The ZAP method aligns with the chemist and McTaggart action research cycle. Problem identification, implementation of the method, observation of students' responses, and refinement of materials. Between 2023 and 2025, the method evolved from a simple name-split approach to a complete instructional kit with a flashcard and an interactive simulation. This innovation makes electrolysis easier to understand by presenting the concepts clearly, visually, and systematically. It boosts students' engagement, confidence, and accuracy in identifying ions and their movement. The teaching aids are simple, affordable, and adaptable to any learning environment. With strong commercial potential, this idea can expand into instructional modules, physical kits, mobile applications, and interactive digital learning platforms. Based on the pre-test and post-test results, students scored 6 marks in the pre-test and 22 marks in the post-test. The difference of 16 marks shows a clear improvement. This means students had limited understanding at first, But after using the ZAP method, their understanding increased and their performance became much better. In summary, the ZAP method provides an effective and innovative instructional strategy for mastering electrolysis. By focusing on zones, direction, and movement, students gain accurate understanding, stronger confidence, and improved performance in electrochemistry. With its proven classroom impact, the method has strong potential for wider adoption and further commercial development.